Okay, so I wanted to give you guys just like some indication of what we're trying to do with this experiment. Our basic goal is to study impact craters. So we're going to use a projectile of some kind, like some kind of ball. We have these in class, but it could be a tennis ball or a golf ball or a marble. And you're going to drop it into a container of flour. If you're working at home, you can use any container. Ideally, it's like deep enough that it's not going to make a huge mess. So like this, I would say, is just barely deep enough. But if you can get something deeper, that's great. Don't use anything glass because you don't want to break it. But you're going to fill that container with flour, and then, let me show you what's going on here. You want to like put some kind of layer on top of it of something that's not the same color as the flour. So you could use, I used paprika. I could also use cornmeal. You want to keep this layer pretty thin. We're able to see that there's a tiny thin layer of something that's not flour on the top. Or with the paprika, it would look like this. We just kind of come along and like shake a little bit of paprika on the top. You may want to ask before you use all your mother's favorite paprika. Some paprika can be kind of fancy, but here's the idea. Let me put it back here so you guys can see what I'm actually trying to do. We're going to do an experiment with an independent variable and a dependent variable. Meaning like, what is the effect of blank on blank? Dependent variable is going to be the diameter of the crater. I'll show you that in a second. But the independent variable is up to you. So if you have a lot of different like objects that you could drop, you could measure the size of those objects. You could measure the mass of those objects. Probably the easiest thing is to take some kind of tape measure and measure the height that you drop it from. Or you can use that to figure out the speed of the object when it hits. Because check this out, I want to show you this first. When we measure the diameter of the impact crater, there's going to be some uncertainty to that diameter. So remember, diameter is basically like the width of the circle. And I might say, oh, this looks like it's about 5 centimeters or so. But we don't want to assume that every single time we drop it, it's going to be exactly 5 centimeters. We need to drop it a bunch of times. Drop it from exactly the same height as I did before, and measure that same diameter for my second drop. So this time I measure it and I get something like, maybe I would call this 5 centimeters again. I would say at least 3 drops for each independent variable value. Another thing that you can do is actually measure the diameter in different places. And so you could make 2 measurements for one crater, like make the longest measurement that you can get and make the shortest measurement that you can get, or something. And you write down all those values so that we can put them on the graph together, and we're able to say like, okay, even when the drop height or the speed or the mass or whatever your independent variable is, even when that is the same value, we're not going to get exactly the same crater diameter. There's going to be some uncertainty in how wide the crater is, because this thing is complicated that we're trying to study. Whatever data you collect, we're going to make graphs from that data and try to use that to figure out what mass and speed of the objects hitting the moon what those masses and speeds have been over the years by looking at actual data from moon craters. Those craters are obviously going to be a lot bigger than 5 centimeters. This type of data, like even though it's just flour in a container, can help us make a model of the same type of collision happening on the moon.